Hello, all you beautiful student scientists. This is Mr. Wickham. We're going to be taking a look at online data collection and analysis today using some online tools for collecting and analyzing data. All right, our objectives today are going to be that you will collect accurate data from an online video or simulation. The basics are the same for video or simulation, but we're using a video today. You'll use a graphing tool online to generate a linear fit of your data for today. We'll worry about more complicated fits like quadratic or 1 over x squared fits later on. But today, linear fits, and you'll share your plot with your peers or teacher. Now, you can do a linear fit on your calculator or on Excel on your computer, but online tools allow you to very easily share that with me or with the colleagues in your class or your lab mates or whatever. So that's why we'll be doing those. The tools, we'll be using direct measurement videos today, taking a look at one of those. Also using Plotly to generate our linear fit to analyze our data. Desmos is another option for analyzing data. We'll look into that later in the year, but not right now. We'll take a look at Plotly today. All right, so let me go to the direct measurement videos website. That link, you can get the presentation on X2, so you can click right there, or just search Google for direct measurement videos and bring up the student video library. We're going to be taking a look at the hill runner today. That's the first video here. Load that up. And I'm just going to press play and then change it to normal speed and see Jesse running up the hill nice and fast, much faster than I can. All right, so now we'll slow it down to 8 times slow motion and we'll play it again. That's more like my speed. That's about how I run. Yep, slow-mo like that. It's much more majestic. It's great. Anyway, so let's reset this, bring her back. We have a couple of tools available to us. The stopwatch up here, which tells us that we're currently at frame 64, but we can reset that to 0, which is nice because we don't care about when she's off the screen. We just care about when she's starting at the origin. That's when time's 0. That's when she's at the origin. Speaking of the origin, we have a ruler available to measure. And so we're going to line this up so that I'm going to put the 0 marker right on her ear. It's going to be easy to measure where she is based on her ear, because her arms and legs and hips and shoulders are moving as she runs, but her head is staying pretty much steady relative to her body, so we'll keep that right there. So our first data point is actually going to be 0 meters at 0 seconds. All right, so I'm going to go over to Plotly, and this is plot.ly, Plotly. I'm going to create a new chart. Now, it brings up, for me at least, because I said, yes, of course I want to try the new version. But the old version, Plotly 1.0, is actually better for this, so click over there if you're already in 2.0. 1.0 allows you to change the column names. They haven't built that feature into 2.0 yet. There's 2.0 still under like alpha development. So some data here about giraffes, orangutans, and monkeys we want to get rid of. Column 1, I'm going to rename that one to be time in seconds, of course. Put the units right on there. And I'm going to rename column 2 to be position. And it's going to be in meters. All right, so my first data point is 0.0000 seconds. And position is 0.00 meters. I'm not going to put any more decimal places than 2 on the position, because if we take a look at this, then we can see that we have decimeter accuracy on these lines, and so the centimeter accuracy is going to be our uncertain value. That's what we're guessing at, basically. All right, so I'm going to go back to my hill running and press play, and stop it again at some point and record a new data point. So 0.1375 seconds. And then my position is going to be 0.68 meters, I would say. 0.68 meters. Great. So I'm going to fill out the rest of this data with her graph, and so I will be able to pause this, and when I come back, I'll jump up and you'll see a bunch more data points. I'm going to get 10 data points total, which is what I like to have for a good linear fit. All right, so we'll see you on the flip side. All right, we're back into it, and you see I've fleshed out the rest of this data with a nice data set of 10 data points. I've saved it as Jesse running uphill. That's what we're going to be working with. And so I'm going to generate a scatter plot once I have all my data. Say generate a scatter plot. I'm going to plot x versus y with the dots instead of doing the line which connects them all. So we'll do a scatter plot. We don't need much of these options right now. We'll worry about this later in the year. But create the scatter plot, and there we go. A nice straight seaming line, which is good. I like to see that. Up at the top, we're going to click to enter a title, position of Jesse running uphill is a good option. So that tells me that, it tells me a position, so I'm looking for a position graph and a position of Jesse running uphill. So it's an informative but clear and simple title. All right, now the things we care about for this are going to be doing a linear fit. That's going to be over here on the left-hand side, this menu, fit data. And we'll add a fit to this trace. It's going to be linear. I'm going to run this fit, and it shows a nice line that looks pretty good. It fits everything. I'm going to add the results as a plot annotation right down here, and that is going to be able to put that equation right on the graph so I don't lose it. Okay. Now, my fit parameters here. 0.003 is my y-intercept, or negative 0.003. Now, I know my intercept should be 0. She started at 0 at time 0. That's what my intercept should be. But because I don't have a perfectly straight line, the intercept the computer wants to give me is slightly off. But notice that the uncertainty in that measurement is a centimeter. It says I'm 3 centimeters to the left of the origin, plus or minus a centimeter, or 3 millimeters. So clearly, I'm well within the error here. So my 0 intercept is actually quite acceptable. It gives me a slope of 5.14 or so, 5.135. And the units for that slope are going to be my y units, which is position, meters, divided by my x units, or time, or seconds. So meters divided by seconds, or meters per second. Okay, well, that means my slope, 5.13, actually tells me how fast Jesse is running. That's my velocity, 5.13 meters per second. She was running in the positive direction. She's running uphill in the positive direction. Her position is getting bigger as time increases, clearly. And so that means that her velocity is going to be positive also. And we see that as a positive slope on this graph. Great. Now, the last thing that we want to do after we save this plot, okay, is we want to share it. We want to be able to share that information. Position of Jesse running uphill is our graph. We'll save that, and we'll be able to share that with the other people in our class. Maybe if I want to share this with Mr. Steves, I can enter in his email address here. All right. Or I can share it with Barack Obama if I wanted to. If I had his email address, I could share it with whomever I like, and they would, as collaborators, they get access to this data, and they can make changes, save it. They can create their own linear fit as well. All right. You can also send a shareable link if you enable this checkbox. Then you can actually email this directly to me, like your teacher, for example, and that would give me an opportunity to view the data and view your graph without getting access to be able to change it. Okay. So I can view it, but collaborators can edit it. So if you wanted to invite me to be a collaborator, you can put my email address in there, and that way I can come in and manipulate your data as well, which I don't know why I'd want to, but you could give me that option. Or you can just email me this link, and that way I can check out your graph and see how you've done and advise you that way. Okay? If you wanted to, you could download this graph as a ping and put that into a lab report, or upload it to a blog, or email me the picture directly. Any of those options would work as well. All right, so hopefully that's a quick introduction to using the direct measurement videos to collect some data, and then plotting that graph using Plotly, plotting the data, and then generating a linear fit, and sharing that information with your friends or with your teacher for grading and collaboration. All right, well, thank you very much. Have a good day. Bye.